Section 3.5 is on inverse trigonometric functions, page 1. So first let's look at a little bit of review in terms of trig. Don't forget that you have your unit circle with the common degrees and radians, degrees 30, 45, 60, 90, and then really starting at 0, but then that repeating pattern through the unit circle, or their radian equivalents of 0, pi over 6, pi over 4, pi over 3, and pi over 2, all creating ordered pair locations on the unit circle where the first value in the ordered pair, the x value, represents your cosine of whatever theta angle you have from the center, and y represents the sine of that theta angle. Last piece to talk about is the ratios for some review. Many of you know the phrase SOHCAHTOA, where SOHCAHTOA could be written as S for sine is opposite over hypotenuse, C is cosine of adjacent over hypotenuse, and T for tangent is opposite over adjacent, where we use the phrases opposite, hypotenuse, and adjacent, thinking of a right triangle that has theta in, it doesn't really matter whether it was in the top or the bottom, it just needs to be in one spot. When it comes to angle theta, you will have a side of your triangle, a length that is adjacent to theta, meaning it runs along one of the sides of theta. You will have a side or a length that is opposite theta because it does not intersect anywhere where the theta angle occurs. And then you have your hypotenuse, which is always across from the right angle portion of the triangle. Don't forget that all trig functions have inverses, which are really the reciprocals. So the cosecant, which is the inverse of the sine, is the reciprocal of the sine. So hypotenuse over opposite, etc. for the next two secant and cotangent inverse functions. Okay, so finishing up our knowledge, we need to start working with our inverse trig functions is two pieces. A equation, I'll say, is a function if it passes the vertical line test, meaning I can draw a vertical line anywhere on the curve or shape of this function, and my vertical line will never intersect the curve more than once. One-to-one functions need to be passing the vertical line test and pass the horizontal line test, which at first glance, this sine function down here, which itself is not an inverse, doesn't pass the one-to-one requirement for an inverse function. So what I need to do is restrict the domain, which therefore restricts the output, the domain being the input. So when it comes to the inverse sine function, I can't go from negative infinity to positive infinity. We're only going to go from -1 to 1, where our range is -pi to pi over 2. So let's look at that, right? So right now, this is not the inverse function. Since it's not the inverse, this is actually the domain, the input of the sine function. So my sine function, if I only use inputs from -pi over 2 to positive pi over 2, I just have this highlighted region, and everywhere on that highlighted region, I pass the horizontal line test. If I restrict the input of the sine function, then its output is only going to reach as high of a value as +1 or as low a value as -1. But if it's the inverse function, using this notation, then remember the domain and range are flip-flopped for the inverse of an original function. So our cosine will also have a restriction for inputs that restricts our outputs, and the same thing for a tangent. I really like this visual down here in the corner to figure that out. We're going to be focused on our answers. what are the answers for an inverse sine function? They're going to go down here from negative pi up here to positive pi. So the first and fourth quadrants, so I wrote sine. The cosine outputs are going to go from 0 to pi. So I went ahead and wrote cosine, overlapping the s from sine. So I know where my output, my answers for the y value will be. And the tangent looks very similar to the sine, but notice the sine has square brackets for output values because we actually obtain outputs at pi over 2 and negative pi over 2. But when it comes to the tangent, don't forget that negative pi over 2 and positive pi over 2 are both vertical asymptotes, and the input for the original tangent function are never going to obtain these values.